This is where we left off last time. We did one example, we made this tree diagram, and we answered some questions. So some things to remind you of from the tree. The first thing, the tree has to start with a single probability. So a single probability. And then if we remember, those two sum to 1. When you go down that branch, you're going to get 2 probabilities that are conditional based on the branch you went down, which again add to 1. Once we go down this branch, we get 2 conditionals that add to 1. And then what we added on was these 4 lines at the end of the table. And to get this probability, which is an and, I multiplied the previous 2. I told you that this question specifically says use a tree diagram. In the future, though, it's not going to say that, and you need to know when to use a tree diagram. A tree is generally appropriate when you have 2 events that are sequential, like one happens and then another one happens, or they are conditional. So you all are going to do an example. I'm going to get us started, though. So if you could go to the next page, this is the example that you have. Many employers require prospective employees to take a drug test. A positive result on this test indicates that the prospective employee uses illegal drugs. However, not all people who test positive actually use drugs. Suppose that 4% of employees use drugs. The false positive rate is 5%, and the false negative rate is 10%. What percent of prospective employees will test positive? Okay, first thing we have to do is figure out what are our events and how can we put them in probability notation. So the first one very clearly is using drugs. So I'm going to let D be that the person uses drugs. So then we're told that the probability of using drugs for these employees is 4% or 0.04. Okay, so here's where it gets a little bit tougher. We don't want to define more variables than we need. So what a lot of people want to do is they want to do false positive is a variable and false negative is a variable. We don't really want that. We need to think about what that false positive actually means. What that false positive means is the person tested positive, but if it's false, they didn't really use drugs. So they tested positive, but they didn't use drugs. False negative, they tested negative, but they actually do use drugs. So what should our second event be if it's not false positive, false negative?
Just like positive and negative in general?
Just positive and negative in general. I will tell you, I don't like to use P as a variable because P is normally probability. So I'm going to use T is test positive. Do we need a variable for testing negative? No. Complementary. Okay, so false positive, again, means the person tested positive, but they don't use drugs. So that is that 5%. False negative, they tested negative, but they do use drugs. That is 10%. So this is all the information that we are given. And we need to know what percent will test positive. So this is what we're looking for. Okay, in my head, when I see 2 conditionals based off of a single probability, that tells me I should use a tree. So when I see those 2 conditionals based off of the single probability, that tells me to use a tree. So I'm going to have you, when I'm done talking with the person next to you, take 5 minutes to see if you can set up a tree. Would it be helpful if I put up here the tree from the other problem? Okay. This is the tree that I got. Okay, so to start with, you need to start with whatever the single probability is that you have. We have the probability of being a drug user. Yes.
Your top number is not right. It's 0.036.
Ah, thank you.
Yeah.
0.036. Okay, 0.036. So the single probability that we have was the probability of using drugs. So then this is the complement. These have to add to 1. Notation-wise, these 2 are conditional probabilities. So I saw in some of your trees it was P of T complement. That's not true. This is T and T complement given drug user. One of them we were given, and just subtract from one. Similar idea here. These two are given, not a drug user. And then ultimately what we probably need is some of the ands. So remember, this and just comes from multiplying the previous two. That is just using the conditional formula. So if we write out the conditional formula, probability of T complement given D complement is the probability of the and over the given. So I'm using this branch. So if I have the conditional, which is 0.95, and I'm looking for the and I have the given, when I multiply them, that's how I get that 0.912. So it's just using the conditional formula. Okay, questions on that before we actually do A and B? Okay, so for A, what % of prospective employees will test positive? So we're looking for the probability of testing positive. This is one we talked about is not a formula. Instead, we say there's only two ways to test positive. Either the person tested positive and they use drugs, or they tested positive and they don't use drugs. Now, let me be very clear with this. On the AP test, a tree diagram is not considered showing work. A tree diagram is not considered showing work. So what I'm saying is I don't want you to just pull this number off of the tree. I want you to show how you got that. It doesn't have to be shown in symbols, but at least numbers. So what I'm going to do is show that I multiplied those two. So for that first probability, I took 0.9 and I multiplied by 0.04. For that second probability, I took 0.96 and multiplied by 0.05. So the probability then of testing positive is 0.084. That's not the final answer though. And why? It says a percentage. Very good. So about 8.4% of employees are going to test positive. Okay on that? Okay, in B, what % of prospective employees who test positive? So given they test positive, what is the probability that they actually do use drugs? This is just the conditional formula. So this is the probability of D and T over the probability of T. Now, D and T, we already showed the work for that before, so I don't need to show the work for that again. Probability of T is what we just found. I guess really not the percent, but this one. Okay, so D and T is that 0.036, and the probability of testing positive is 0.084. So the probability then of D given T is 0.429. So in the long run, if we look at everybody that tested positive, only 42.9% of those people actually use drugs. Isn't that very counterintuitive? Has anyone ever had to take a drug test for a job? Yeah. Okay, this is probably not the most accurate number, but it's not an incredibly high number. So if you ever take a drug test for work and you test positive, the very first thing they do is test you again because of the high rate of false positives or false negatives. Okay, this is just going to involve some practice, which you will get. Okay, so here is my question for you. There is a way to do this using a two-way table. I think this makes a lot more sense. Do we want to see the way to use a two-way table, or are we happy with our tree? Tree? Okay. We have a few other things to write down then. Oh. Okay, do you guys have anything else on this page? No? Great. Do you have this multiplication rule for independent events? Okay. If we start with the conditional formula, we get probability of A and B over the probability of B. And like we just saw, if I solve this for the probability of A and B, I get the probability of A given B times the probability of B. You guys agree? I just took the formula and solved for something different? Okay. Here is the big deal if the events are independent only. So if the events are independent, then the probability of A and B will be equal to, if the events are independent, what is the probability of A given B?
Whatever A is.
Probability A.
Just the probability of A. So if the events are independent only, the and can be found by multiplying the two individual probabilities. But again, only if the events are independent. Okay. We have 2 more examples, and then we are done with notes. Okay, the first trimester screen is a non-invasive test given during the first trimester of pregnancy to determine if there are specific chromosomal abnormalities in the fetus. According to a study published in the New England Journal of Medicine in November of 2005, approximately 5% of normal pregnancies will receive a false positive result. Assume that women's test results are independent. Among 100 women with normal pregnancies, what is the probability that there will be at least one false positive? Okay, so we're told we're only looking at women with normal pregnancies. This 5% is for the normal pregnancies. The probability of a false positive is 0.05. The reason I'm not writing this in conditional is because I already know I'm only working with women with normal pregnancies. Okay, so it asks us, what is the probability of at least one false? So at least one false positive. That means we need the probability of 1 false positive and the probability of 2, all the way up to the probability of 100 false positives. So that is one option. We could go about calculating 100 different probabilities and adding them up. Obviously, we don't want to do that. Any idea what we could do instead?
Well, we could
Josh?
Do 1 minus the probability of 0.
Yeah, exactly. We're going to do the complement instead. So anytime you see that at least 1, the only case I'm not interested in is if there are 0 false positives. And again, that's if you see at least 1. The complement is generally easier. So if a false positive is 0.05, not a false positive is 0.95, but then we raise it to the 100th power for all 100 women. So really what we're doing is 0.95 for the first woman, 0.95 for the second woman, 0.95 for the third, all the way up to 100, hence that 100th power. So this is about 0.994. So about 99% of the time, there's going to be at least 1 false positive. Questions about that before the last example? Okay, stick with me for the last example. This will be quick and then we're done. On a recent day, the Arizona Daily Star forecast a 50% chance of rain in Oro Valley and a 50% chance of rain in Marana. What is the probability it will rain in both locations? Okay, probability that it's going to rain in Oro Valley is 0.5. Probability that it's going to rain in Marana is also 0.5. Probability that it's going to rain in both. So remember that symbol in the middle is and. What a lot of people want to do is they want to say, well, I'm just going to take those 2 0.5s and multiply them. Can we do that? Why not?
They're not independent.
Not independent. So this one we cannot answer. Because we are not told if they're independent or not. And in all likelihood, probably not, right? If it's raining in one location, it's likely to be raining in the other.